Hello everyone, welcome to my channel uLearn Education Online. In today's video, we are going to discuss the concept that is the designing of voltage to current converter circuit using op-amp. Before entering into the concept, let us discuss what is the need of designing V2I converters and the use of V2I converters. Since these V2I converters are mainly used in industrial applications and the instrumentation, and where these V2I converters are used, let us see. And also what is the need of using V2I converters. So as we know that if you consider some industrial applications, the sensors will be present at a particular distance and the display unit is presented far away from the sensors. Means between the sensor and the display unit there exists so much of distance. Okay, for example, if you consider that one sensor is placed at a particular distance from the industry, and here this sensor is used in order to express or in order to display any change in the physical environment. Let us consider I am taking one temperature sensor. If there is a change in the temperature of an environment, this sensor simply detects the change in the environment and it simply produces the voltage value. Now this voltage has to be transmitted at a particular distance in order to reach the display unit. For example, let us say that this display unit is present in the industrial area or in industries. So this voltage value should be traveled at particular distance in order to reach the display value. So if I consider this graph, so with the increase in the distance, this voltage value will gradually decrease while it is transmitting through the cable. So here there exists some voltage drop. In order to overcome this drawback, here a voltage to current converter should be used. So here if the voltage to current converter is used, which means that here the sensor voltage should be converted to the current by using a V2I converter circuit, and thereafter this current will passes through the cable. Okay, if I consider some distance and it is the current I, here the current will pass through some constant value with minimum change in error. Okay, now this current value will be displayed at the display unit. Here in this way, if there exists a change in a temperature in the physical environment, by using a voltage to current conversion circuit, here it will display the correct value without errors. And also we know that whenever the signal is passed through the physical environment, there exists a noise. So if the voltage is directly passed through the physical environment, it is easily affected by the noise and also its value will be overlapped by the noise. Whereas if the current is passed through the physical environment, there is a minimum change in the value with respect to the noise. So for this mainly purpose, this V2I converters are mainly used. And also in a lab experiments, these voltage to current converter circuits are mainly used in order to test the components and also in LED applications, that is in order to measure the brightness of an LED for different voltages and also the color combinations. So in all these particular applications, this V2I converter using op-amp is used. So this is the need, or this is the application of V2I converters using op-amp in both industrial and the practical theory experiments. Okay, now let us see what is the circuit of V2I converter. Now let us see the V2I converter circuit designing using op-amp. Okay, so here in order to design any V2I converter circuit, first the circuit should accept the input signal as voltage and the output that should be measured as a current. Okay, so here this V2I converter circuit should operate in the linear mode. We know that the linear mode is nothing but if there is a change in the input signal, the output signal should respond to that change and it has to display the value. That is, the I out is always proportional to the V in. So it is directly proportional to the input voltage. For suppose if there is a sudden change in the input signal, the output should change. Okay, so this is the V to I converter using op-amp, that is the concept. And also depending on the connection of a load, these V to I converters are divided into two types. One is the V to I converter with the floating load, and the second one is the V to I converter with the grounded load. Okay, now depending on the applying of input signal with the op-amp input terminals, again this V to I converter with floating load has two types. One is if the input signal is applied to the non-inverting terminal, how the circuit response will be, and if the input signal is applied to the inverting terminal, how the circuit response will be. We will see in this next video. Okay, now let us see the first one, that is a V to I converter with the floating load. Okay, so here this is the circuit. If you observe here, this input signal is applied to the non-inverting terminal of op-amp, that is we can say that it is a non-inverting V to I converter with a floating load, since the input is applied to non-inverting terminal, and here this load is connected between the two terminals, that is floated. Okay, so for this circuit we have to measure the output current and how it will respond with the input voltage, and what is the relation between the output current and the input signal. Okay, for mathematical analysis we are making the assumption that is the op amp is in ideal condition. Okay, so if the op amp is ideal, we can easily apply the virtual ground concept. So as we know that the virtual ground concept is nothing but the currents entering at the op amp terminals are zero. Okay, and also the difference voltage Vd is 0. What do you mean by the difference voltage? The voltage at the non-inverting terminal is always equal to the voltage at the inverting terminal. For suppose if I consider point A as a node point at inverting terminal of op amp and point B as a node point at non-inverting terminal of op amp, so with the help of this virtual ground concept, the Vb value is always equal to Va value. Okay, from this circuit, this VB value is nothing but the input voltage. So I can say that this VA is directly applied to the input voltage unintentionally. Okay, now simply apply KCL at node A. So if you apply KCL at node A, we get what is the entering current? It is the load current is the entering current and leaving current is the IT from that node A. We can know that the sum of entering currents is equal to sum of leaving currents at a KCL point. So it is entering current is IL and leaving current is IT. Okay, so we know that IT value from the circuit, it is IT is VA minus 0 by R1. So VA value is input voltage, that is IL is equal to, finally it is V in by R1. Okay, so finally if you maintain this resistor value R1 as constant, we can say that the load current IL is always directly proportional to the input signal Vin. That is, even if there is a change in the input signal, the circuit quickly respond to the change and it will produce at the output current as a reading. So this is how the V to I converter with floating load with the non-inverting input signal applied. Okay. Now let us see what happens when the input signal is applied to inverting terminal of op amp. Okay, so this is the circuit. Here this input signal is applied to the it is applied to the inverting terminal of op amp, and here the non-inverting voltage is 0. It is connected to ground. I am assuming it as same voltage node A and it has node B, since here it is VB value is equal to 0, since it is easily connected to ground potential. Okay, so same assumptions we have to take while we are did in the previous concept, that is we are assuming that the op amp is ideal. So if op amp is ideal, we can apply the virtual ground concept. Okay, so what do you mean by virtual ground concept? That is Vd value is equal to 0 implies the node potentials at the inverting terminal and the non-inverting terminal are 0. Here VA value is equal to 0 unintentionally since VB value is 0. Now simply apply KCL at node A. So if you apply KCL at node A, we get entering current is I1. So it is entering current is I1, which is equal to leaving current IL. Now what is the value of I1? It is VI minus VA by R1, which is equal to VI value is 0, which I by R1. I can say simply it is IL is equal to VI by R1. So we can get the same expression. Okay, by maintaining this R1 as a constant value, even if there is a change in the input signal, the circuit should quickly respond and it will produce the change at the output signal in the form of a current. So this is how we have did mathematical analysis for the V2I converter with the floating load. Now let us see the second concept, that is V2I converter with the grounded load. Okay, so this is the circuit for the grounded load V2I converter. Here this input signal is applied to the non-inverting terminal of op-amp, and here the load is connected to the ground. That is, one end is connected at input and the second end is connected to the ground. So this is the grounded load. Now we have to calculate the value of IL, whether we have to see whether it is directly related to the V in or not. Okay, now repeat the same procedure as we did in the V2I converter with the floating load. That is, we are assuming that the op amp is an ideal condition. Okay, so here virtual ground concept is applicable. That is, VD value is equal to 0 implies VB is equal to VA. Okay, now simply apply KCL at node A. So if we apply KCL at node A, we get, now what are the entering currents? Entering currents is I1 and I2 and the leaving current is IL. Now what is the value of I1? So I1 is VI minus VA by R plus I2 is V0 minus VA by R, which is equal to IL. So finally the value of IL is 1 by R into VI plus V0 minus 2VA. So this is the value of IL. Okay. Since it is a non-inverting terminal of op-amp, we can know the basic expression of output voltage for the non-inverting op-amp circuit is V0 is equal to 1 plus RF by R1 into input voltage VI. Now what is the value of RF? RF is R and R1 is R, and here this input voltage is nothing but the potential at the node B. Okay, so which is equal to 1 plus R by R into VB. So R gets cancelled. So finally the V0 value is 2 times of VB. I can write, since VB is equal to VA, we can write it as a 2VA. Now simply substitute this value in this expression. We will get IL is equal to 1 by R into VI plus V0 is 2VA minus 2VA. Now plus 2VA and minus 2VA will get cancelled. So finally the value of IL is equal to VI by R. Same expression we derived for the grounded load and also for the floating load. Okay, so this is how we have to design the V2I converter using op-amp circuit, and also we have seen how the inverting terminal and the non-inverting terminal of op-amp with floating load is designed, and also with the grounded load, and also we have seen the mathematical proof how the load current will change according to the change in the input signal. Okay, so this is the concept of V2I converter. If you have any doubts, please share in the comment section, and if you really like this video, please subscribe to our channel. Thank you.